Assalamualaikum and hi guys. My name is SYAHIRAH binti Abdul Latif. My matric number is 179629. So today, my friends and I, we are going to present about free radicals in atmospheric chemistry and biochemistry. Okay, so I want to explain about the atmosphere, which is there are 4 regions of atmosphere. So let me draw first. So this is our Earth, and then here in our atmosphere, this is a troposphere layer, and then stratosphere layer, mesosphere layer, and thermosphere layer. But in our presentation, we will focus on troposphere layer. Okay, so what is meant by troposphere? So troposphere means a turning sphere, which is symbolize the fact that in this region, convective processes dominate over radiative processes. So troposphere contains the bulk of atmospheric water vapor, the majority of clouds, and most of the weather, both on a global and a local scale. Okay, so here the bulk of dry air is made up of nitrogen and oxygen. Other than that, we have the noble gases, carbon dioxide, and a large number of other minor gases constitute the remaining 1% of atmosphere. So, to explain more about troposphere, so my friends, which is ATHIRAH Husna, will explain more about what is the formation of radical that happen in troposphere.
Okay, thank you, Shahira. My name is ATHIRAH Husna binti Shafie. My matric number is 179793. And my part is I'm going to explain about reaction involve hydroxyl and hydroperoxyl radical that form in troposphere region. So we know that a variety of radical species are encountered in the atmospheric chemical reaction, and the most important radical species among them is the hydroxyl-free radical, which it plays a central role in many atmospheric chemical reaction. It is formed in the troposphere by a variety of means, but the most important is 4 step processes, including 2 photochemical steps. So firstly, the nitrogen dioxide will absorb sunlight to produce nitrogen monoxide and oxygen atom. And later, oxygen atom will react with oxygen gas and a third body, for example, N2 or O2, to produce O3, or we call it ozone. And then the ozone will undergo photochemical process, which will absorb sunlight and produce excited oxygen and also oxygen gas. And this fraction of the excited oxygen will react with water to produce 2 mole of hydroxyl radical. So this is one way to produce radical, which is hydroxyl radical. And there are one other way that to produce radical in troposphere region, which is by photolysis of water. Which is the water will absorb sunlight in the troposphere region and produce hydroxyl radical and hydrogen radical. So when the radical is being formed at the troposphere region, the radical need to be removed from the troposphere region. So to remove the radical from the troposphere region, it will react with either carbon monoxide. The hydroxyl radical will react with either carbon monoxide or it react with methane. So there are 2 ways to remove the hydroxyl radical from the troposphere. We can see here that hydroxyl radical that being removed by methane will produce highly reactive methyl radical, which this highly reactive metal radical later will react with oxygen gas in the presence of the third body for stabilize of the reaction to produce a methyl peroxyl radical. So we know that radical have very short shelf life and it's very reactive. So since they are very reactive, they can trigger other formation of other radical by react with other molecule. So we have learned, we know that radical will form will undergo propagation step to trigger other radical. Like firstly we have hydroxy radical, then react with other molecule like methane to produce a methyl radical, and methyl radical trigger formation of methyl peroxyl radical. So the hydrogen radical that produced in early reaction will react with oxygen gas to produce a hydroperoxy radical, which an intermediate in some chemical reaction. So this hydroperoxy radical can either undergo change termination reaction or a regeneration of hydroxyl radical. So in change termination reaction, hydroxyl radical can either react with hydroxyl radical, or it can react with the other mode of itself, which is the hydroperoxy radical, react with hydroperoxy radical to give water and oxygen, or hydrogen peroxide and oxygen gas. So we can see here that all the product that form from the reaction, showing that the ability of the atmosphere to cleanse itself from accumulation of pollutants with the chemical conversion to non-polluting constituent such as water and oxygen gas. That's all from me. So I will pass to my other member to present about the biochemistry.
Hi, meet me again. So I will continue to give some introduction for my other member part, which is ZULFA. She will explain about the free radical in biochemistry. So what is free radical about? So a free radical can be defined as a chemical species possessing an unpaired electron. So it can be also considered as a fragment of a molecule. So free radical can be formed in three ways, which is first by homolytic cleavage of a covalent bond of a normal molecule, second by loss of a single electron from a normal molecule, and third by addition of single electron to a normal molecule. So the most important reactant in free radical biochemistry in aerobic cells are oxygen and its radical derivative, which is superoxide and hydroxyl radical, hydrogen peroxide and transition metal. So before I pass to ZULFA, so this is the normal oxygen, and when we give the electron to the oxygen, and it will form the free radical like this. So ZULFA will explain on oxygen, free radicals and reactive oxygen species in biochemistry.
Okay, Assalamualaikum. My name is ZULFA binti ZAWANI. My matric number is 179609. Okay, now I will explain about how free radicals are formed in cell, and it can be two parts, which is the normal and abnormal. And normal is called physiologically and abnormal is pathologically. Okay, so for the normal, the example is the oxidative phosphorylation, which happen in our body, and we know that this is a super important process to make ATP to be used by the cell in our body. So this is the cytochrome C oxidase, which will give electron to oxygen, and this will in turn cause the mitochondria to pump up the H+, and it will create a proton gradient that drive the production of ATP. Okay. Normally, for oxygen to be stable, they will accept 4 electrons to become H2O. But what will happen if this oxygen does not get all the 4 electrons? Okay, so firstly, when oxygen accept 1 electron, it will become the superoxide anion, the first free radical. And then when it accept 1 more electron, it will become hydrogen peroxide. And when it accept 1 more electron, it will become hydroxyl radical. So these 3 electrons received by the oxygen is called partial reduction. And means it does not receive all 4 electrons to reduce to become water. Okay, so that's how radical is formed in for normal condition in our body. Okay, so now I will explain how free radical are formed pathologically or in abnormal condition. Okay, so first is the ionizing radiation. Okay, so this happens when radiation comes and it strikes the molecule of water, and it will knock off the electron. So if you go backward when from water and it gives off 1 electron, it will form hydroxyl radical, which is the most reactive radical, and it will probably cause damage to your cell. Okay, the second step for the formation of free radical pathologically is inflammation. So for inflammation, when you get infection, neutrophils will come and help to fight that infection. So there are 2 mechanisms that can be used to kill whatever microbe that there is oxygen dependent and oxygen independent reaction. So for this one, we will focus on oxygen dependent reaction, and of course it uses oxygen in this process. And for this process, an ADPH oxidase will convert the oxygen to superoxide, and for in further reaction it will form a bleach. However, we will focus on the first reaction, which is where the free radical form, and this will the free radical that will cause some damage to your cell. The third cause for the formation of free radical is caused by the metal. So in our body, there are copper and iron that bind to some things, such as the transferrin. So if the iron or copper is not bind to something, it will cause the formation of free radical, and this process is called Fenton reaction. Okay, so how actually the free radical damage our cell? Okay, now I will explain how free radical attack the lipid membrane. Okay, first, okay, this is the free radical. So it will attack the lipid membrane, and it will take 1 electron from the lipid, and then this electron will go to the free radical, and this causes the lipid membrane to have a one pair of electron, and it means that the lipid membrane has become a free radical, and it will attack the next membrane to take the electron from the neighboring membrane. So and they can propagate this process in a sort of chain reaction, and this can hurt the cell membrane and damage the whole of the cell. Okay, that's how the free radical can attack the lipid membranes. Thank you.